For today's video, we will be talking about halogenation. So for this, it's a reaction that consists of an alkene reacting with a halogen element, so either bromine or chlorine. So for example, we have an alkene, and this is reacting with chlorine. All we do is just redraw the structure and add the chlorine on the sides where the double bond goes. And so for this is the product for this. Next, if we have this structure, and this was reacting with two bromines, we redraw the structure, and we just draw the bromine on the side of the double bond where it was. And so for this halogenation, it is an anti-addition. And so we would have one wedge and one dash, and plus an enantiomer if it has one. In this case, it does. So a wedge and a dash like this, anti-addition. Now, for this problem, the structure is reacting with chlorine, right? And so how would we determine if it has one or two products? Well, the thing is, we can see if it's symmetrical, right? So is the left side equal to the right? No, they're different. So if it's not symmetrical, then it would have two products. But if it is symmetrical, it would have one product. The reason for it will be meso compound, the same thing. But also, we can also check on the double bond. If we split it right here, is the left side and the right side the same? This side with this side? No, they are not. So this is a asymmetrical molecule. That means it would have two products. Okay, so for this, we would redraw the structure. Now for the methyl group, we know that this carbon over here is a chiral center carbon. For that case, we put the methyl group a wedge for now, and we have the chlorine sticking out over here, and we have a wedge on the other chlorine. Right now, plus is an enantiomer. The same thing. Now the methyl group would have the wedge. The chlorine would have the dash, and the chlorine down here would have the wedge. So these are the two products for this. Now for this next structure, so if we have this, and this is reacting with bromine, two bromines to draw this product, we do this, redraw the molecule, and to see if this is asymmetrical or symmetrical, draw a line between the double bond, where the double one's at, and we see that the left side and the right side are similar. They are the same. So this means that this will only have one product, right? And so the BRs would come over here, and the other BR would be over here. And also you can tell that these carbon are not chiral centers because they don't have four different elements or compounds. So in fact, there is no wedge or dash for this. It's just a straight line, and it only has one product. Now one more example for the products. If we have this structure, and this is reacting with chlorine, and you were asked to draw the products for this. We redraw the molecule. And so if we cut this in half, we see that the left side and the right side are similar. So that means it would have one product. But also, we can tell that this molecule on the left is a trans structure. So meaning it comes off the opposite side. So this, in fact, whenever you see a trans structure molecule, just remember it only has one product. So for this, we would have the bromine over here, and then the bromine down here. Only one product. Now let's talk about this mechanism. If we have a structure like this, double one right here, and this was reacting with bromine, two bromines, right? So the first thing you want to do is draw out the two bromines. Okay. Both these bromines have two lone pairs. 3 lone pairs. So the first thing you want to do is the pi electron would go to the bromine because this is nucleophilic. It's a Lewis base. Now these electrons would go away to the second bromine, and this lone pair would go back to the structure, right? And so we would have a 3-membered ring, cyclic membered ring. Redraw the structure, right? Have the methyl group over here, and we would have it connecting to both the bromines. And this is called a bromonium ion, bromine with a positive charge. Now we have the other bromine that is negative, 4 lone pairs, negative charge. Now, since we have a wedge for the bromine, you can either put wedge or dash. This has 2 mechanisms for this structure, and it has 2 mechanisms. That means it will have 2 products as well. So for this, we're only doing 1 mechanism. We see that the bromine is attached to a wedge, meaning wedge means front. So that means the other bromine, the negative charge bromine, has to come from the back. Okay, it has to come and attack from the back and attack on the carbon that has the most substituents. So like this. So then this would react with, right when you do that actually, the lone pair, the electrons from carbon that is holding the bromine would go back onto carbon, so making it a neutral charge. So then this will give a structure of other bromine hit from the back, so that means it'll have a dash, right? So this is it, but let's change the methyl group. So the methyl group, that carbon is a chiral center. These both carbons are chiral centers, so that means they must have a wedge and a dash. So the methyl group can have can actually have a wedge first. That bromine would have a dash, and the bottom bromine would have a dash as well. Wedge plus, it's an enantiomer. The methyl group would have a dash. This bromine would have a wedge, while the other bromine on the bottom would have a dash. And so these are the 2 products for the mechanism that we drew out. Next, if we have a structure that looks like this, the double ones right there, and this is reacting with 2 chlorines, right? So draw the chlorines first. Both chlorines connected. They both have 2 lone pairs, 3 lone pairs. So this is halogenation. So this is an anti-addition. Start from the double bond goes to chlorine. Well, this electron will give off to chlorine. Well, this lone pair from chlorine will go back on the structure, and so we will get a result of a cyclic membrane. I'm going to put a wedge. You can put a wedge or a dash, doesn't matter. Just remember, if you put a wedge, that means the other chlorine has to hit from the carbon from the back. If you put a dash, the carbon will hit the front, the chlorine would hit the front carbon. So but for this case, I'm going to put a wedge. It has a positive charge. Chlorine has 2 lone pairs. Now the other chlorine would be over here. Fix that. The other chlorine is a negative charge, and it would hit the carbon that has the most substituents. But in this case, they both have the same amount of substituents, so it doesn't matter which carbon you hit. Let's draw the chlorine. I'll just pick the bottom one. The other chlorine has 4 lone pairs, goes and attacks the carbon. That carbon gives off its electrons to chlorine, which will give us a product of this. Okay. Also, plus it's an enantiomer. So we can see that this is an anti-addition. And these are the 2 products for the mechanism that we drew. Now for this next structure, we would have this, and this is reacting with two bromines. So the first thing we see that this is a trans structure molecule, so that means it would have only one product. But also, if we cut it down right at the middle, we see symmetry on the left and the right side. So in fact, this would have only one product. So through this mechanism, we'll draw out two bromines, both having 3 lone pairs. Pi electrons go to bromine. They get off that electrons to the other bromine. Now the lone pairs on the first bromine goes back to the structure. This will give us a cyclic membrane ring. So bromine, positive charge. Now the other bromine is negative. We would hit the carbon from the back based on this on the carbon that has the most substituents. So for this case, they both have the same amount of substituents, so it doesn't matter which carbon we attack. Just pick one from the backside. Now this carbon gives off electrons to the bromine, which will give us a reaction of a final product of this bromine coming off, this bromine going off. Again, it's only one product. This is a trans molecule, has symmetry. So this is the final product for it.